Hello everybody, this is the notes for section 3.2. In the first section we talked about what it is to solve a system of equation. We talked about solving it by graphing and by using the substitution method. So today it's just a different method. It's not any better than the other ones. Well, it's better than graphing, but it's not better than substitution. It's really just, it depends on the equation. Sometimes substitution will be easier, sometimes elimination will be easier. So we're going to talk about the process of elimination. We're also going to talk about some weird answers that you might get. All right, so take a second to copy this down. Yeah, do that, please. Okay, the idea of elimination method. Basically, you got two equations, two variables. You need to get rid of one of those variables and one of the equations. So the elimination method, you're going to multiply by a number, either both or just one equation, to get the coefficients of one of those variables to be equal and opposite. And so then when you add those equations together, you get, one of those variables will be eliminated, negative 2x plus 2x. That's 0. So you're just left with the other variable, and you can solve for that. Okay, so there's your steps. Let's do an example problem. Okay, so it didn't say eliminate x or eliminate y. It's just whichever one is easier. All right, so I'm looking at these two equations here, and I'm looking at the x's. I think this is going to be the easiest, but you can eliminate the y's just as easy because they're already opposite signs. But I'm seeing 4x and 8x. I'm going to multiply that first equation by a negative 2. And so what that gives me is negative 8x plus 6y equals a negative 30. I didn't want that line. We didn't do anything to the second equation, so that's just going to stay the same. Okay, now that you've got the x's to be equal and opposite, we've got a negative 8x and a positive 8x. You're just going to add your equations. Okay, this is what it means to combine the equation. Negative 8x plus 8x is 0. 6y plus 2y is 8y, and that equals a negative 40. And one of the first step on the previous page said to line up the variables. It's not needed, but it's kind of nice. X's all lined up in a row. Y's, equal sign, constants. It just makes the adding that we did here much easier and cleaner. All right, divide by 8 to solve for y. We get negative 5. There's part of our answer. We're missing the x value. So go back to one of the equations, so the original ones, it doesn't matter which. 4x minus 3 times negative 5 equals 15. Just plugging in the y value, solving for x. Subtract 15, we get 4x equals 0. That means x is 0. So our answer is the point 0, negative 5. Okay, that's the elimination method. It's about the same number of steps as the substitution method. Just like I said, sometimes elimination is easier, sometimes substitution is easier. It just depends on the equations that you're starting with. All right, hit pause, take a second to read through this. Okay, so you've got a couple of things going on. Trying to raise funds, the English club, sounds so fancy, selling poetry cards and bouquets of flowers. So you got a couple of things going on here, so it's kind of helpful to just kind of focus in on those certain things. You've got some discussion about cost, all right? So I'm going to use the red pen for the cost information. Cards cost $2 each. Bouquets cost $3.50 each. The club will go down a sentence. The club will spend $360. So there's some more information about the cost. All right. Also start talking about selling them, bringing money in. So selling the cards for $6 and bouquets for $8. And then the club will spend this from their account, and their expected revenue is $900. So we got a bunch of things that are related to each other. Now let's write some equations. The question is, how many cards and bouquets can be obtained and sold? So we've got two sets of different things going on. We got cost and we got revenue, money being brought in, okay? We also, in each one of those, we've got two other things. We've got number of cards, number of bouquets. There's our variables. So C equals cards, number of cards, B equals number of VOU, Q, blah, blah, blah. All right, so cost information. Cost $2 for each card. So if C is the number of cards, 2 times the number of cards, plus it's the cost of $3.50, so 3.5 for the number of bouquets. When you add up how much it costs for all the cards and all the bouquets, they wanted to spend $360. There's your first equation. The other equation, other information, was related to selling the stuff. So number of cards they're selling at $6 each, so 6 times C. They're also selling bouquets for $8 each, and they were expected to bring in a total of $900. There's our system. So you can use substitution. We're talking about elimination in this section, so let's do that. What I'm going to do is multiply top equation by a -3. So we get a -6C, that's a minus, 10.5B equals a -1080. Left the second equation the same. And now when we add these equations up, the C's go away. We're left with a -2.5B equal to a -180. Solve for B, you get 72. Now, need to solve for C. So, the next step is plugging this back into one of the original equations. So plus, it was, where did my original equation go? Oops. 3.5B. So 3.5 times 72 equal to 360. So 2C equals 252. Oops, that's a plus. The 3.5 times 72, that's 252. That equals a 360. We're just solving for C. So I subtracted the 252 from both sides, divide by 2. So, question was, how many cards and bouquets can be obtained and sold? 54 cards, 72 bouquets. That is it for this section, of this video. The next one we talk about what happens when certain things, weird results, and how to interpret them.